Okay, so today we're going to talk about phase shifts. Phase shift is just a fancy word for a horizontal shift of a trigonometric function. And that talks about that C value that we were looking at in the computer lab. So steps to graphing with A, C, and D changes. You should have most of these steps down already. Number 3 is where we're really going to focus in. So you're still going to identify and draw your midline, identify and draw your maximum and minimum, and then number 3 is the important one. Mark your x-axis with the starting x values and 4 values to the right. So if we started at 0, and we looked to the right, let's list a couple of x values that we would see on a trig graph. So let's start at 0. So 0, we know that pi over 2 comes after that. Then we have pi, 3 pi over 2, and 2 pi. And those are our normal 5 values. But when we start having shifts, we need to add some in front of that and behind that. So we know that all of these values can be negative as well. So let's look at more positive values. After 2 pi, we would then see 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So you should see a pattern here of how to add each increment. And like I said before, all of these can go negative. You would just need to make sure that you're working backwards. So 0, negative pi over 2, negative pi, and so on and so forth. So let's pull in here would be our midline, our maximum and minimum. And this is how I want you guys to start marking your x-axis. So here would be the starting value. So whatever that C value is would go on this line. And that, again, is our C value. And then we would go 4 places after that. So 1, 2, 3, and then 4. So if this were maybe negative pi, then we would have negative pi over 2, 0, pi over 2, and pi as our 5 critical points. The last 2 steps are the same as they were before. You plot your 5 critical points from your starting value. That would be different. And then draw your curve. So let's actually graph this one. So y equals cosine of x minus pi. Our a value in this case is 1. There was no number written in front of cosine, so we could assume that's 1. Our c value is opposite of what we see in the equation, so it's just pi. Our d value in this case is 0 because we have nothing written after our function. So going through our steps, our first step is to identify and draw our midline. That comes from our d value. So our midline is at y equals 0. Our second step is to do our amplitude or our maximum and our minimum, which our maximum is 1 above our midline and our minimum is 1 below our midline. Because our amplitude was 1. Now what I accidentally clicked a moment ago was actually where we're going to start. We're going to start at our C value, which is pi. So we would label this pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, And now we need to make sure that we have 4 points after our starting value. So again, our starting value was at pi, and we had 1, 2, 3, 4 spots. So we know that that is our end. Once we do that, where do we know that cosine graphs start? If it is a positive cosine graph, it's going to start at its maximum. So we'll have our first point on its maximum. Our second point will be at its midline. Our third point will be at its minimum, midline, and finally at its maximum. And then we draw our curve through all of our 5 critical points. Okay, so that's how we would graph when we have a phase change. Mark your start and end points so that you know where that cosine curve should be. So now that we've looked at one with just a phase change, let's actually look at one with everything on it. So our A value, what would our A value be in this case? A is -3. Our C value and our amplitude being a +3, or the absolute value of A. Okay, our C value is always opposite of what we see in the equation. So it is a -pi/2. Again, that is our starting point, or our starting value. And our D value is a +1. So let's go through our steps. We will identify and draw our midline, which comes from our D value. So we know that that should have been at y = 1. We will identify our maximum and our minimum, which, because of our amplitude being 3, is 3 spaces above, 1, 2, 3, and 3 spaces below, 1, 2, 3. Please remember that the maximum and minimum are always counted from your midline. So it's not just a positive and a -3. Notice that the minimum is actually at -2. It's 3 away from the midline. Okay, then we're going to identify our starting point and our ending point. So we know that we need to start at -pi/2. So let's go negative. So -pi/2. Okay, so we know that our starting value is here at -pi/2, and we need 4 spaces away. So 0 is 1, pi/2 would be our second one, pi is third, and our final place will be 3 pi/2. So marking our start at -pi/2 and our end at 3 pi/2. This is a negative sine graph. If there is a negative, I want you guys to put an arrow at that negative and say that it is a reflection. Okay, so remember that our normal sine graph goes up, then down, then back to midline. Our reflected sine graph will first go down, then up, then back to midline. So we know that sine starts at the midline. So on our starting point, we are at the midline. On our next point, we're going to be going down because it is a reflected graph. At the third spot, we'll be back at midline, up to our maximum, and back to our midline. And our final step is always to draw our curve. Try your best to make a curve. Sometimes they end up a little bit triangular-ish, and that's okay as long as you understand that it is a curve and not a linear graph. That is it for today's video lesson. Thank you guys.